Imagine your app just went viral. Thousands of users are pouring in every second, and the single server handling your traffic suddenly buckles and crashes. Your first instinct might be to scale up by buying a bigger machine with more CPU and RAM. While this is simple, you eventually hit a hard physical ceiling, where the hardware literally cannot get any larger. Because you are still relying on one machine, a single component failure takes your entire service down. The alternative is scaling out. Instead of one supercomputer, you buy dozens of cheap, mass-produced commodity servers and split the work among them. This path is practically unlimited. You just keep adding machines. However, adding more machines immediately breaks the system's simplicity. You now have to figure out how to route requests to the right machine and how to keep all those separate servers in agreement. Every complex tool in a distributed system exists solely to solve a specific problem created by this decision to scale out. To solve the routing problem, we install a load balancer. It acts as a gatekeeper, using algorithms like round robin to spread requests evenly across the group. It also performs health checks, automatically stopping traffic to any server that crashes, so users never see errors. With multiple servers, you cannot store user data locally. If a user logs into server A and their next request goes to server B, the system will have forgotten who they are. We solve this by making servers stateless. They look everything up from a shared external store, ensuring any server can handle any request at any time. Funneling every request to a database is slow. To speed things up, we add a cache, a small, extremely fast store of data kept in RAM. By intercepting repetitive reads, the cache delivers data up to 1,000 times faster than the database. For static files like videos or images, we use a specialized cache called a content delivery network. If your main servers are in Virginia, a user in Tokyo normally pays a high cross-ocean delay. A CDN places an edge server in Tokyo, serving that file in milliseconds. Caching involves a major trade-off. Because you are serving a copy of the data, that copy becomes stale the moment the original changes. Caching always trades data freshness for raw speed. Extracting state and repetitive data away from your servers removes the immediate processing bottlenecks, but it introduces the permanent risk of users seeing out-of-date information. Even with a cache, a single primary database eventually becomes a bottleneck. If that database fails or gets overwhelmed by updates, your whole system stops. We scale read capacity through database replication. You designate one primary database to handle all writes and changes, which then streams copies of that data to multiple read replicas used only for queries. This creates replication lag. Because it takes time to stream the copies, a user who posts a comment and refreshes immediately might hit a lagging replica that hasn't seen the update yet, making the comment appear missing. In an interview setting, remember that replication does not solve storage limits. If your disk is 100% full, adding more replicas just gives you more machines that are also 100% full. To solve for storage or heavy write loads, you must use sharding. This involves physically splitting your dataset into pieces called shards. You might put users A through M on one database and N through Z on another, so each machine manages its own slice. The danger here is the hot shard. If you shard by username and a wildly popular celebrity is on shard 1, their traffic will crush that single machine while your other shards sit idle. Replicas duplicate the entire dataset to handle more reads. Shards divide the dataset into pieces to handle more writes and storage. Jumping straight to a complex, sharded architecture on day one is a common mistake. Doing so adds massive complexity before you have actually outgrown a simple setup. Follow a strict escalation path. Start with a single server, then add a load balancer and stateless apps. Only add caches, then replicas, and finally sharding when the load genuinely forces you to. Every step up this path buys you more capacity, but it costs you in system complexity and maintenance overhead. Every new machine is one more thing that can break. A mature system uses these 6 blocks in harmony: load balancers, stateless servers, caches, CDNs, replicas, and shards, to ensure that no single machine is a bottleneck or a failure point. Senior engineering requires the judgment to know exactly when to stop adding these blocks and accept the current system's limits.